Okay, let's look at how we would find the parameterization for a few of these curves. First of all, this circle, x squared plus y squared equals 4. This is just going to be 2 cosine t, y equals 2 sine t. And if you want the complete circle, t is going to go between 0 and 2 pi. So this is just basic ones. Now, if you shift the circle over horizontally 1 unit and vertically up 2 units, um, or down 2 units, what you're going to have is you're going to have x equals uh, 2 cosine t plus 1, y equals 2 sine t minus 2. So that will give you a circle centered at 1, negative 2. Now, same thing, t is going to go from 0 to 2 pi. Now, if you want the circle to go, these will give you circles that are going counterclockwise. They're traced out counterclockwise. If you want to go clockwise, you could just change the x could be 2 sine t, the y could be 2 cosine t, so forth. Now, for this ellipse, you could do this. You could say, well, x is equal to 2 cosine t, y is equal to 3 sine t. Okay, so these are just some that it's good to just have, in your mind, okay, I know how to find a set of parametric equations for a circle and ellipse. Now down here, this line segment, what we think about with this line segment is we notice that this thing is going to go from 0 to, and it's going to end up over here at 4, 0. Yeah, 4, 0. And what I like to do when I'm modeling a line segment like this, I'm just going to have t going between 0 and 1. This makes it easier for me. So I'm going to say, okay, let's see here, x and y. X starts off at 0 and it ends up at 4. So let me make that 4t, right? Because when t is 0, x is 0. When t is 1, x is 4. That's that's what I want it. Now, as far as the y goes, I want it to start off being 2 when t is 0, but 0 when t is 1. So I maybe 2 minus 2t, like that. That would do it. So there I have found a parametric representation for each one of these curves. Now let's go the other way. Instead of finding a parameter, let's get rid of the parameter. So these ones, we've got, a lot of times they're very straightforward, like this one here. We've got 12a, x equals t plus 5, y equals 2t minus 4. We just solve one of the equations for t. For example, that first one, I get that t is equal to x minus 5, and then I plug that in to the second, there, like that. Of course, you could then modify it. You got 2x minus 10 minus 4. You get 2x minus 14, if you want to go further with it. Here we have, that's a circle. We recognize that's a circle immediately. So this is x squared plus y squared equals 5 squared, 25. Now this one looks a little bit tricky because solving for t is a problem. However, notice you can do this. You could say, let me find. Let's see here, y minus x. Let's see what that's going to be. It's going to be t squared plus t minus t squared minus t. Let's see what that gives you. Y minus x equals 2t. Ah, see, the t squares are gone. Now you get t is equal to y minus x over 2. Perfect. Now, if I want to, I can go back up and say, okay, then y is equal to y minus x over 2 squared plus y minus x over 2. There, we've eliminated that parameter. Okay, now let's consider a curve here. And on the practice problems I gave you, I didn't really specify, but let's just make t go between -10 and 10. We'll just do that. And we're asked to find the x and y coordinate when t is equal to 2. Okay, so let's see. When t is equal to 2, we get x equals 2 and y is equal to 2 squared plus 1. See, I just plugged back in. And we get this, 2 comma 5. Then we're asked to find the slope of the tangent, dy dx, when x is equal to 2. I mean, when t is equal to 2. Okay. Now, there's a so let's look at this. What we're going to do is we're going to take the derivative of the y with respect to t, and we get 2t. The derivative of x with respect to t, and we get 1. So it looks like what we have is 4. Yeah, if I just put a 2 in there. And now an equation. Now, on the problems I gave the class, I have find an equation for the tangent when t equals 1. Well, I've done the groundwork here for when t equals 2. So that's what I meant. I meant for you to find the equation for when t is equal to 2. So remember the equation for a line, we can use this form. We get y minus 5 equals 4x minus 2. And there we have it. And there's our equation for the tangent. Okay, now let's suppose we've got this expression here and we want to write this in polar form. Well, okay, so this is the first part. So I get r squared is equal to 16. In place of x, I'll put r cosine theta. Now I want to solve for r. So I get r squared minus 16r equals, well, 16r cosine equals 0. Factor out the r. Now, you could, if you want, you could divide through by r and get there quicker than what I'm doing this, but that's really a bad habit to be in. I prefer to go ahead and do it this way because sometimes if you get in the habit of doing that, then you'll lose roots or you'll lose important information. So we get r equals 0 or r equals 16 cosine theta. There is my r. Now, I want to find, I'm getting ready to find dy dx in this form. So what I need to do is I need to recognize that x is going to equal r times cosine theta. Remember, that's what x is, r cosine theta. Y is r times sine theta. So here's what we've got. We've got 16 cosine squared theta. And this one, if you look at it, this is going to be 8 times 2 cosine theta sine theta, which is 8 times sine 2 theta. Just use a little trigonometry there. Okay, so there's x and y. Okay. Now I want to find what I'm working toward is an equation for a tangent at pi over 6. So I want to find the coordinates when um, when theta is equal to pi over 6. So the x coordinate is going to be 16 cosine pi over 6 squared. That's going to be 16 times, let's see here, that's square root of 3 over 2 squared. So that's going to be 3 over 4. And that's going to be 12, right? Because 16 divided by 4 is 4. 4 times 3 is 12. And then we get the y. which is going to be 8 times sine pi over 3. See, if I put a pi over 6 in here, that 2 makes it pi over 3. So that's going to be 8 times square root of 3 over 2, which is equal to 4 square roots of 3. There we have it. So here we have an ordered pair. We're getting ready to write an equation for a tangent. And we need a point and we need a slope. Now let's find the slope. Okay, so this is going to be part C in your handout. So we've got dy dx. Okay, so I'm going to take the y. So up top I've got 16 cosine 2 theta. I'm just taking the derivative of this thing, the y, over the derivative of the bottom. Okay, so this is going to be 32 cosine theta times negative sine theta. Let me just put a negative out front there. Okay, so let's see what this is going to be. Negative. Okay, up here I've got 16 cosine 2 theta. And down here I've got 16 times 2 cosine theta sine theta. Yeah, that's it. And these 16s go away. So I'm left with negative cosine 2 theta over 2. Oh, what am I doing? Sine 2 theta. See, because this. Okay, well then, we're about ready to find dy dx at theta equals pi over 6. So what it's going to be, it's going to be negative cosine pi over 3 over sine pi over 3. See? Because when I put pi over 6 in there, I get pi over 3 because I multiply it by 2. Now let's see what that's going to be. This is going to be negative square root, woo, almost messed up there. Negative 1/2 over square root of 3 over 2. That's going to be negative 1 over the square root of 3. So there's our slope. And now we're ready to write the equation. The equation is going to be y minus the y coordinate. I can't remember what the y coordinate was. Oh, 4 square roots of 3. 4 square roots of 3 equals negative 1 over the square root of 3 times x minus 12. There it is. Okay, now let's find the area of the shaded region up here. Okay, now we've got two circles here. We've got x squared plus y squared equals 9, x squared plus y squared equals 16. So let's right away convert those to polar. So r equals 4 and r equals 3. Now, so we're going to integrate this. We're going to do 1/2 integral from alpha to beta of the outside, 4 squared minus the inside with respect to theta. And we need to figure out what our bounds of integration are because we're going from y equals 1/2. Well, that's going to be arctan of 1/2 x, all the way up to arctan 2. So arctan 1/2 to arctan 2. Because look, this is, if we have whatever x is, y is 1/2 of it. So it's going to be 1/2 over x. So um, remember how we went through and we found what the bounds of integration are. Now, all I need to do is integrate here. This is going to be arctan 1/2, arctan 2. So this is 16 minus 9, which would be 7. So here we have 7/2 theta from arctan 1/2 to arctan 2. Okay. And then we would just use the fundamental theorem of calculus for evaluating that, and we would have our indicated area.